Hello. Hello, all. So happy Global Math Week to everybody. So I have a question. And the question is, what is 1/4 in base 3? So what does that mean? 1/4. So I want the decimal representation of 1/4 or 1/4 in base 3. So I guess we're trying to find 1 divided by 4, but doing that in base 3, meaning we're going to be using a 3-to-1 machine, right? So here we have, as you can see it, there we have our 3-to-1 machine. Right now, first of all, I guess, what does 4 look like in base 3? Well, if this is a 3-to-1 machine, then what does that mean? That means that our rule, right, is that we count dots always in the rightmost box. Whenever we have now 3 dots in any box, they're going to explode. They go kapow, and they become 1 dot, 1 box to the left, right? So if we put in 4 dots, 1, 2, 3, 4, we have an explosion, right? 3 of these dots explode, kapow, kapow, and they become 1 dot, 1 box to the left, and we're done, right? So the code for 4 is going to be 1, 1 in a 3-to-1 machine. So, and what are the boxes? Well, remember, in any box in a 2-to-1 machine, well, our boxes are powers of 2, right? Because if we're in a 2-to-1 machine, well, 2 1s made 1 2, 2 2s made a 4, 2 4s made an 8, 2 8s made a 16, and so on. But here, we're in a 3-to-1 machine, right? So therefore, we have that 3 1s make a 3. So the rightmost box is still 1, but then 3 1s make a 3, and 3 3s make a 9. Kept going, 3 9s would make a, I guess, 27, 3 27s. What is that? That's 81, right? And we keep going. And our boxes are powers of 3. So the question here is, what is 1/4 in base 3? So 1/4, a fraction, is just a division problem, right? So we're taking 1 divided by 4 in a 3-to-1 machine. So what does that look like? Well, I guess we just start with 1 dot, right? Oops, there's 1 dot. And we're saying, well, how many 4s are there in 1? Well, I guess don't be silly, right? There's no 4s in 1. Okay, but remember 4 in base 3, we just did it. We saw that 4 looks like 1 dot next to 1 dot, right? The code for 4 in base 3 or in a 3-to-1 machine is 1 1. So 1 dot next to 1 dot. So we have 1 dot. I want this pattern. I want to find how many groups of 1 dot next to 1 dot we have in 1. Well, there's none, right? So what can we do? Well, I mean, remember, in any machine, right? We could always unexplode. If we were in a 2-to-1 machine, 2 dots make 1 dot, and if we have any dot in any box, we can always unexplode it, go backwards to 2 dots in a 2-to-1 machine. In a 3-to-1 machine, well, again, 3 1s make 1. So if I had 3 dots in this box, well, if I had, right, if I had 1 dot in this box, oh, there we go, right? I could always unexplode that to 3 dots going backwards, right? So, but I start with 1 dot here. Well, I guess if I had more boxes, I could unexplode going backwards, right? I don't have any boxes. Well, why can't we have more boxes? And we know we can, right? Because if we have boxes going this way, well, do these boxes have any meaning? Well, I think they do, right? Because in this case, going to the left, we know our boxes are powers of 3. 3 1s made 3, 3 3s made 9, 3 9s made 27, and so on. So if the same rule applies, then 3 of these would have to make 1 of these, right? So 3 what? Make 1. Well, I guess 3 3/3, right? Or 3 1/3 would make 1. So this box would have to be worth 1/3 or 1/3. And then, well, 3 of what make 1/3? I guess that has to be 1/9, right? And then 3 of what make 1/9? I guess that's 1/27. And we see that our boxes are just, well, there's still the powers of 3, but now they're reciprocal. Powers of 3 going to the right. Cool. So I guess we have this 1 dot here. And I'm saying, what is 1/4? Or 1 divided by 4. So how many groups of 4? Again, 4 looks like 1 dot next to 1 dot. And I don't see any right away, but what we can do, we can unexplode, right? So take this dot, unexplode it, zoop, into 3 dots going this way. So 1, 2, 3. So that's still just 1 dot, right? Because I have 3 dots in the box. They explode, kapow, and become 1 dot, 1 box to the left. So yeah, that's still just 1 dot. But now, okay, well, I guess I still want to have groups of 4. And I only have 3 dots here. So there's still no groups of 4. I still don't have 1 dot next to 1 dot, which is what 4 looks like in base 3. What else can we do? Well, what do you think? I guess we could do it again, right? Because if I take any 1 dot, unexplode it, the 3 dots going to the right. So zoop, right? That's still just 1 dot. Those would explode to 1 dot, and that would explode to 1 dot. So this is still just 1 dot. But now look, I'm looking for 1 dot next to 1 dot, and do you see it? Yeah, right here, right? Here's 1 dot next to 1 dot. There's 1 group, and remember, we do division, right? All the dots really reside in the rightmost part of that loop because an explosion had to have happened that spilled over the other dots. So I have 1 group here at this box, which I guess is the 1/9 level. So I have 1 group here, but then 1 more, right? Right there, 1 dot next to 1 dot. Again, at the 1/9 level. So I have 2 groups here. I have no groups here, right? Both groups are at the 1/9 level. So I have 0 groups at the 1/3 level. And then I have, I guess, 2 groups. So I put it as 2, right? I have 2 groups at the 1/9 level. But then look, I have that 1 pesky dot that's still left over. So what can we do? We just go ahead and unexplode it again, right? Take this 1 dot, unexplode it, shoop. Right? We're in a 3-to-1 machine, so therefore that becomes 3 dots. But again, no 4s. Okay, we'll go ahead and just unexplode one of these dots, shoop, into 3. And then boom, we're looking for 4, which again looks like 1 dot next to 1 dot. And again, right here, 1 dot next to 1 dot, 1 dot next to 1 dot. So again, both of these, I guess is now this would be at the what? This is 127th, this would have to be 181st, right? But then I have 2 groups at this level, 0 groups at this level, but again, 1 dot left over. So go ahead, do it again, unexplode that dot, and you would see again, 0 groups at this level. You could unexplode, have 2 groups again, and you can be doing this for a very long time, right? You're doing this forever. So we see that 1/4 in base 3 must be equal to, well, there's no groups at the 1 level. And then you could put, a dot or maybe a point, right? That's a point to separate our 2 sides of the machine. And we see that 1/4 in base 3 must be equal to 0.020202. And that's going to repeat forever. All right, so we see a repeated decimal, 0.02. We could put this, if you want, as just 0.02. Put a baniculum over that to just say that 02 is going to repeat forever. All right. So yeah, that's pretty cool, right? And we see that, again, 1/4, there it is, the decimal representation of 1/4 in base 3. All right, take care. I hope you're enjoying Global Math Week, and there's a lot more Global Math fun that's going to be continuing for the rest of this week and then beyond that as well, right? So everybody take care, and I'll see you soon. Bye-bye.